this section of the programme, we will look at the recommended equipment for giving oxygen to a child. We will also look at how to connect up and use the equipment. The commonest method of supplying medical oxygen in small hospitals is from a cylinder. Another promising method is using an oxygen concentrator. However, for oxygen to be given correctly to a patient, several more items of equipment are needed. These can be divided into the items which allow the oxygen flow to be controlled, monitored and transported to the patient, and those items which come into direct contact with the patient. First, we'll look at the oxygen cylinder and the equipment to be connected to it. Always check that the cylinder you're about to use contains oxygen. Oxygen cylinders may be marked differently in different countries. For example, oxygen cylinders from the United States of America are often green. Some other countries follow an international system of using white cylinders for oxygen. This cylinder is marked in a way which is common in British Commonwealth countries. It is black with white shoulders. You may also see O2, the symbol for oxygen, marked on the cylinder. If in any doubt, check with your supplier on the accepted marking in your country. Make sure that the oxygen cylinder is secure and cannot fall over. Never use any kind of oil or grease to lubricate joints, as this may create a fire hazard. Never put a naked flame anywhere near an oxygen supply. A regulator and gauge are connected directly to the oxygen cylinder. They reduce the high pressure in the cylinder and keep the flow constant as the oxygen is used up. A flow meter is connected to the regulator to control and monitor the flow of oxygen to the child. The methods of oxygen delivery shown in this video require only low flows of oxygen of up to 2 liters per minute. In order to accurately measure the flow and ensure the maximum flow does not exceed this level, a 0 to 2 liters per minute flow meter, which does not allow higher and potentially dangerous flows, should be used. If humidification is required, such as when a nasopharyngeal catheter is used, a humidifier is then filled with clean water and attached to the flow meter. Cylinder oxygen is completely dry. The humidifier adds moisture to it. Strong plastic tubing, which will not easily bend and interrupt the oxygen flow, is then used to take the oxygen to the patient. Special non-crush tubing should be used that does not kink or twist. A hand wheel or spindle key is used to turn on the oxygen at the cylinder. We'll now watch the steps to connect the actual equipment together. Before connecting anything to the oxygen cylinder, check that it's properly secured and remove the cylinder seal. Fresh cylinders come with a plastic film seal. Larger cylinders have a protective metal dome. In this demonstration, we'll be using a cylinder which has a bullnose valve. Carefully attach the regulator to the connector on the bullnose valve. Only a reasonable amount of force needs to be used to tighten the regulator to the cylinder valve. Never use excessive force or over-tighten connections. You may find that instead of a bullnose valve, your oxygen cylinder has a pin index valve. The pin index oxygen valve has 2 holes which correspond with 2 metal pins on the pin index regulator. They ensure that the regulator can only be attached to an oxygen cylinder, and therefore this system is safer. Where possible, cylinders with pin index valves should always be used. As with the bullnose valve, Only a reasonable amount of force needs to be used to tighten the regulator to the cylinder valve. The pressure on the regulator gauge may be shown in kilopascals, pounds per square inch, or bar. This gauge is marked in kilopascals. This oxygen cylinder has a pressure of 16,000 kilopascals when full. It should be replaced if the pressure falls below 800 kilopascals, as it is about to run out. Next, connect the flow meter onto the regulator. The flow meter must be vertical, or the reading it gives will not be accurate. Since some flow meters are read at the top of the ball and some in the middle, make sure you know which is correct for your flow meter. If a humidifier is required, fill it with clean water to the level marked on the jar. Use either distilled water or tap water which has been boiled and cooled. Next, attach the humidifier firmly but not too tightly to the flow meter. Take care doing this, since oxygen leaks often occur at the point where the humidifier joins the flow meter. Next, attach the oxygen tubing to the humidifier. Make sure that the oxygen tubing is pushed well onto the humidifier nozzle, as leaks can also occur here. Slowly open the cylinder valve until fully open. On this type of oxygen cylinder, this is done with a spanner. Some larger cylinders have a hand wheel control. Then adjust the oxygen flow with the knob on the flow meter. On this flow meter, read the flow from the middle of the ball. It is showing 0.5 of a litre per minute, which is half a litre per minute. The assembly is now complete. A second source of oxygen is an oxygen concentrator. Oxygen concentrators require an electricity supply to operate, and they work by physically separating oxygen from the air. Compact, reliable machines that comply with specifications issued by the Acute Respiratory Infections Programme of the World Health Organization are now available. They may provide a cheap oxygen supply in small hospitals, and at the same time overcome the difficulties of transporting cylinders over long distances. Oxygen concentrators, complying with the World Health Organization specifications, can give oxygen at a flow rate of up to 4 litres per minute. This model has a built-in flow meter and has an indicator to confirm the concentration of oxygen delivered. If the concentration of oxygen falls too low, an orange, then red warning light comes on. If the concentration continues to fall, the machine switches itself off. The source of oxygen you use will be determined by what is available in your hospital. Having connected the items which allow the oxygen flow to be controlled, monitored and transported to the patient, you are then ready to select the equipment to deliver the oxygen to the child.